link right here. What?
Go.
This link right here is a link to a document I keep with more links on it, and it's got links to a whole bunch of useful web resource things that I've come across in learning web programming. And one of the things you'll find on this document is a link to my performance document. So if you just look on that previous document that you'll go to from that link, for perf, P-E-R-F, you'll find this, which is notes I made when going through various trainings to learn about performance. And the thing that you can look for there is what you'll hear about when you learn about performance is something called the critical rendering path. And this is the path that needs to occur for a web page to be displayed to a user. So the very first thing at the top, the client sends the request to the server, and then the server responds. You know, and you see there it says send as little data as possible. So I make little notes about there, how do you increase performance. But then it goes through 5 steps in the critical rendering path. The first one is to get the HTML, and this is known as parsing. So when you're in Chrome Dev Tools and you're in that timeline waterfall, you'll see keywords like in the image there, you see recalculate style being highlighted. And that's one of the things you see. Well, recalculate style is happening in the second step. Parsing is happening in the first step. The third and fourth step, you have layout occurring. And the fifth step is being painted on the screen. And you can read about what those different things are: parsing, recalculate style, layout, painting. And you can also scroll down this document and see best practices for optimizing performance. And there's a, just sort of like a 10-point checklist that you need to do. But when you go back into the Google Chrome Developer Tools, you see stuff in here. Now you can look at that stuff, like you'll see parsing, you'll see recalculate style, you'll see different things, you'll see layout. And so when you see that, you can be like, okay, layout, that's occurring on step 4, where we're figuring out the sizes, the geometry of the different things we want to put on the page. And then you use all that to sort of just understand what the browser's doing to show somebody a web page. The end.
Cool.
Hopefully
Thanks.
it's a helpful resource.
Yeah, that
If you
definitely
do
looks
that
helpful.
again, walk up, because the audio is much better for your stuff.
Sure.
Okay.
All right. So yeah, that should be very helpful. Couple more things on timeline that's helpful to see, and that's the memory panel. So if I check that memory box, I get this fun thing right here. And this is showing the memory in use currently in the browser. So it's only the JS heap here, so my total memory, and then my documents, nodes, so these are my DOM nodes, and then listeners, any event listeners. And you'll see this sort of change, and you'll see it change over time. So let's see if I can get anything interesting here. If I reload this, this isn't a particularly interactive page.
What's the scale there?
So the scale is going to vary based on what you're actually doing. So and the scale is different for each of these the different numbers, right? So actually, sorry, no, it's the same scale, but the scale is going to vary. So if it's going to compress it if there's not a lot of nodes, or if there are. These are the bytes in your heap here, and this is the number of documents, number of nodes, number of listeners. So 24.
Good gazillion.
It's probably 2 meg. Yeah, we're looking at 21 meg to 24.2 meg. Yeah, so you can see the difference here. The one thing that you'll notice over time, and we may not be able to see it here, because here the memory just keeps building up and up. You usually get to a point where you see sort of a sawtooth kind of pattern, where you see kind of an up, down, up, down, up, down. And whenever you see those downs, those are usually garbage collection events. That means that the browser has decided to collect a whole bunch of nodes, and you can get rid of them. And you'll notice that. There's no exact, this is a good memory footprint or this is a bad memory footprint, but depending on what you're doing, you can try to get a better idea of this. Again, these are pretty low-level optimizations, but depending on your application, these might be helpful. This gets important as you start to build up more interactive applications. Applications where you have, that are long-running. They're like single-page applications, is what we call them. Applications like Gmail, for example, where you don't really do a page reload, you just keep on using the application. All right, so then we have profiles. That's this next tab, profiles. And we can select one of these profiles to run. And these are built-in profiles in Chrome that we can run and get some idea of what's going on. Heap snapshot will give us the memory distribution. Heap allocations will give me the object allocations over time. And JavaScript CPU profile will tell me the execution time for my application.
All right, so what is heap?
So heap is where all your memory nodes are, your memory objects are going to be. It's your collection of memory.
Sounds like something I'd see at the dump.
Yes, so heap is a data structure, which is the data structure used to store objects in memory. So when we say heap, we're talking about the memory on your page. So these might be plain old JavaScript objects, you might make up normal objects, or you might have DOM nodes, which we know are objects, but they can be bigger objects because DOM nodes are very big objects. So if I, for example, take a snapshot, it's going to run this, and it's going to give me a whole bunch of information here about that. Again, it's pretty low level, and you probably wouldn't be looking at it normally, but you can get some information here.
JavaScript generally manages the heap a lot by itself. You don't have to worry about it usually too much.
Yes.
Knowing that if you've got this big object, you might want to mix it to null when you're done using it.
The only thing that's really interesting is when you start writing very DOM-intensive applications, you might end up with a lot of references to DOM nodes that are no longer there. That's when you have to start thinking about memory problems. If you do event listeners that you bind, but you don't unbind, that's a problem if you get rid of the nodes in the meantime, because your DOM objects are still going to be there, but or you got rid of the DOM objects, but you still have references to them, so they can't be GC, can't be garbage collected. Then audits is the last tab, and these are reports that you can run in Chrome DevTools to give you information about specific topics, and there are only 3 that are available. There's accessibility, which we'll be talking about later in the week. There's performance, and there's network utilization. I'll give you an example of performance here. If I select reload page and run audit on load, it's actually going to reload this for me. And run the audit finished. Now it's just going to give me some helpful, actionable items that can be done on this page. So I could optimize the order of my styles and scripts. I can remove some unused CSS. I can get rid of my vendor prefix CSS names that I don't need. Things like that. These are just like actionable items that it suggests for you.
That looks like the page speed insights Google developers that
Very similar, yeah.
that the first guy showed us.
Yeah, very similar to page speed, yeah. And you can do things like, accessibility here if I reload. And a lot of times it's helpful to run these audits on page load, so you get to see as things load. You'll run the audit. This one's apparently taking some time. Or maybe it's not going to finish.
Wow, Google doesn't really follow their own accessibility rules, do they?
Well, it just doesn't, it could be broken in the new, I'm running a beta version here, so.
Google's not worried about being indexed by search engines.
But like network utilization, it will tell me, so it'll tell me, hey, maybe I should have enabled gzip on certain resources, things like that. So, we just, oh, you can also click this to open console. That opens that, or the drawer for the console drawer. And then you also, finally, you have this little gear that brings up the options. We've already looked at that for the Shadow DOM option to show the user agent Shadow DOM. So we just went through a lot of DevTools. I know it's a lot to kind of digest. Definitely spend some time with DevTools. I think something like this where we go through them is helpful. But it's really, you're not going to learn them until you actually use them. And you're going to find what works for you. Some of these pieces might not be helpful for whatever you're using, or maybe you just prefer to find your information some other way. I know some people like to do the whole step through and debugger point in the source panel. Some people prefer to use the debugger call out in their code. Some people still like to use console logs and just put those down and get a sense of what the data is at any particular point. There's no right or wrong way. It's whatever makes you most productive and most able to do your job in terms of building applications. Any questions?